Okay, 1.3, segments and their measures. First off, we're going to continue on. If you remember in 1.2, we talked about defined terms and undefined terms. That's kind of the basic building blocks we're going to be using in our reasoning that we're using to prove all sorts of different things in geometry. So, uh, well, what a postulate is basically a accepted statement. Um, an axiom is just another word for postulate. They're the same thing. Just different books use different words. So our book used postulates, and whenever you read a postulate, there's no real proof of it. It's just accepted. Euclidean geometry is the geometry that this book is based off. There's other types of geometries. We're not going to get into that right now, but that's something you could look up. There's things like called hyperbolic geometry and taxicab geometry. Um, some interesting things happen when you look at the accepted statements that this guy Euclid he first wrote down. When you change one of those and say, "Hey, I don't accept that. I'm gonna rewrite it," you can end up with a whole different branch of geometry. Um, So, our first postulate in this book is the ruler postulate, and basically that says um, I can measure the distance between 2 points. Okay, absolute values, think about as distance. You know, if I say, how far is it from Lanesboro to Fountain? You say 10 miles. Well, from Fountain to Lanesboro, it's still 10 miles. It's not negative 10, it's always positive. So, these absolute values are saying they're positive. And the ruler postulate basically says we subtract the two. So this is the important part from the um, ruler postulate. Postulates, I might not even write these down because they're accepted statements. You've probably accepted them for the past 10 years. Probably don't need to start writing them down. So AB without any line over it is called the length of the segment AB. So there's a difference between AB and the segment AB. Okay, this is talking about a length where this is talking about a geometric figure. Okay, so here's an example. If I wanted to know this distance, this is here at 3 3/4. Well, I could subtract this point A, which is at 1, to find the distance of this segment 2 3/4. So that's the length of AB. Notice no notation over the top. Postulate 2, another accepted statement, uh, it says is a segment addition postulate. This one is pretty important. The important piece basically is probably the picture um, and then this part right here. Okay, so I'd write this down, and then draw the picture. That's key. What the segment addition postulate is saying is I can take this segment and I can add it to this segment, right? So I'm going to erase this for now, but AB, segment AB plus segment BC, those lengths AB plus BC equals the total from A to C. So the red part plus the green part equals the blue part. Once again, pretty common sense, especially if I put some numbers in here, 3 and 4. How long is the blue line? 7. How'd you get that? You added 3 plus 4. I think we're just going to skip that. This is an example. You could pause it and try it on your own if you want, but pretty straightforward using that segment addition postulate. The more important thing in this chapter section is using this distance formula. This is a very important formula. You're going to use it throughout all the chapters basically. It's something that you might want to take and write down in the front cover of your notebook. Put it somewhere where you can find it, and make sure you write it down right. I get a lot of people that mess up and they write it down, and then they get the wrong answer, and it's kind of sad when that happens. But distance formula, that's the key, and then basically you can write that down. You don't need to write all the words, but we can use that to find the lengths of different segments. Okay, and we can find all these different lengths. I think I'll maybe just do one of these, and then you can try the other ones. But if I want to find the length of segment EF, so I'm finding a length, so I don't need to put any marking over the top. The length of EF, let me move this over so I got some room to work. And it's helpful if you just memorize your formulas. I know my teachers always said, oh, you got to memorize this formula. And it is important, but I'm not going to say that you have to yet. It's x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And I'll tell you a trick for memorizing it. For me, it's really easy because I know this little trick, and I can relate it to another theorem. You'll see in a bit. But x2 and x1, these 2's and 1's don't mean anything other than they help us differentiate between the 2 points. Okay, so if I come over here, I'm looking for EF, these 2 points, I'm looking for this length. So as I do that, I'm just going to call one of these points 1 and point 2. Okay, I arbitrarily pick which point is which. Arbitrary means on a whim. I just picked it, and now my x coordinates. Now remember, x y coordinates. So x1 refers to my x coordinate of my first point. x2 refers to the x coordinate of my second point. So if I kind of draw some lines, I'm going to be taking this -3. That's my x1. And my x2. That's my x coordinate of my second point. So they get plugged in, the 1's and 2's go away. That's just helping me find the right point, right? And I'll do the same thing with my y coordinates. So that's my y1 goes here, and my y coordinate of my second point goes here. Y2 second point. That's all that 2 means. So putting it in, it's the square root of 1 minus -3 quantity squared plus y2 is 3 minus y2 is 2. Let me change that. That's my second y coordinate minus 3 quantity squared. So from here, I simplify this, and subtracting negatives like adding. I get 4 squared plus -1 squared. Now, I would highly recommend at this point, if you're putting this in your calculator, I get a lot of people, remember, you can't put it in your calculator like this. When you put it into your calculator like that, your calculator will tell you -1 like this. But you want to put it in your calculator in parentheses, because here the calculator thinks of this as more like -1 times a 1 squared, which is -1. You want the calculator to think -1 times -1, which is +1. This is what we want. We want a +1 there. So I'd highly recommend just either not put the negative sign in when you're squaring it, or just do it in your head. So 4 squared is 16. -1 squared is 1. The answer is the square root of 17. That's the length of that segment there. You can hardly even see it anymore. Okay, um, so um, so when the lengths are equal, the segments are said to be congruent. Okay, so this new word congruent. Congruent means they have the same length, or if we're talking about angles, they have the same measure. So we'll talk about that in our next section. Now, there's another way to do the distance formula, and this is the one I prefer to use most often, is if I'm trying to find the length of this black segment here, what I'm going to do is I'm just going to use the Pythagorean theorem. This is that theorem that helps me remember the distance formula. But basically, I'm just going to draw in a right triangle, and I can count the sides. This has a side length of 3. This has a side length of 5. Put that up here. And then the Pythagorean theorem is that a squared plus b squared equals c squared. Okay, where a and b are the legs, the 3 and the 5, and c squared is what we're looking for, our length. Well, if I'm looking for this length, I need to take the square root of 3 and 5, or 3 squared and 5 squared. So I can then get 9 plus 25, 34. That's the length of that segment. So I think I like this method. I think it's faster when you have a picture. Now, if you don't have a picture, you probably are going to need to use the distance formula. We'll have a picture quite often, so it's nice to know both of them. Make sure you can do the other one. But if you have a picture, it's easy to count that length. And how I can remember the distance formula is basically, if I want to know this length, remember that ruler postulate? If this is my x-coordinate 2, and that's my x-coordinate 1, right? Here's x and x. If I want to know this length, I just take x2 minus x1. Now, what did I do? I squared it. Okay, so x2 minus x1 tells me this length. So if this is at a 3, this is at a 2, well, I took 3 minus, that's a negative 2, minus negative 2, and that was that length of 5. That was the number that we just counted. So it's just a lot faster just to count it. Okay, the distance formula comes from the Pythagorean theorem. And feel free to go back and look at the distance formula, Pythagorean theorem. Make sure you have it in your notes. When it comes to the test, if you can show me that you have some sort of idea of what the distance formula is and how to use it in your work, you can get some partial credit. It's that easy. So feel free to go back, make sure that's in your notes, understand it, ask questions, and I think you're going to have a lot of success in this class. So everybody have a good night. I'll see you tomorrow while we work on these problems, okay? So write those down in your notes so we can get started right away.